Okay, this next one has an E in each of those. So this one's going to require the calculator because you have E raised to different decimals and different numbers, so definitely you probably want to use your calculator on this one. Whenever you put a number in your calculator, if you have E raised to any number, that's going to be above your ln key. So above the ln key on your calculator, you should see a little E caret or E raised to the X, a button like that. And that's what you're going to use to do each of these. Now the first row we don't actually need a calculator because we can use log properties for this one. So first one you have E to the 0, and we know as a review from the pre-calc material, anything raised to the 0 power is always equal to 1. And you have E to the negative 0, that's also equal to 1. So you get 1 comma 1 is your starting point. Now we're going to fill in the rest of these. Next thing we're going to do is we're going to put in E to the 0.5. Now E to the 0.5, that one you'll have to do on your calculator. So if you put that in the calculator, you should get 1.65. So you can check it with your calculator with these numbers that I have here. I have them already done already, but you want to go ahead and check these for yourself. Okay, so you have E to the negative 0.5, and so remember when you put that in your calculator, don't forget the little negative sign that's got to go in there with it. This is going to give you 0.61, so 1.65 and 0.61, that's your next coordinate. Then we have E to the first power. E to the first power, that's a constant, that's 2.7. And then we have E to the negative 1, and that's going to be 0.37. So you get 2.7 and 0.37 as the next coordinate. Keep on going. E to the 1.5. You want to put that into the calculator. E to the 1.5 is going to be we'll just do 4.5. We'll just do one decimal place on that. And then E to the negative 1.5 is going to be 0.22. So we get, for here we get 4.5 and 0.22, so we can see that the Y values are falling as we're going down there. We have one more, we have E squared. E squared is going to be 7.4. E to the negative 2, that's going to be 0.14 if we just use two decimal places. So 7.4 and 0.14 is the last coordinate. So again, you had to use a calculator on that one, but the main idea here is whatever values you get here for T, you're always going to substitute them into each formula here. You'll be able to get your corresponding X and Y values. Now we have a list of points that are here. So these points now are the ones that we now want to plot in order to get the graph. So let's do that next. So again, hopefully you had some time to write that down. Otherwise, pause the video. We'll erase this, and we're going to now do the graph. Okay, so when you make a graph, you kind of want to look at what kind of scale to make your graph in order to fit all the data in there. I noticed that the X values, the smallest one is 1 and it goes all the way up to 7. So now I've got to have at least 7 going down there. So I need to make this 7. 7 and a little bit more. That'll take us over to here. That's enough to get the X values. The Y values, the largest one is 1. So I'm actually going to put 1 right here, because that way I can have a better idea. It'll be easier to plot it. So I have this is 7 here, and that's a 1 there. Now let's go ahead and plot the points. So you have 1, 1. So 1, 1 is right here. Next, 1.65. So a little bit more than a half, 1.5 there, and then 0.61 would be probably about right here. And we're just going to estimating that. 2.7. So here's 2.7 there, and 0.37, probably something like about this. And then next we have 4.5, 4.5 and 0.22, approximately right here. And then 7.4 and 0.14 will be about right there. So what we have here is we have a graph that's actually falling and going down, looks something like this, and it's hitting our points just like that. So it starts here and it goes down that way. The directional arrows would be these, so don't forget about those. It's going from left to right. Graph starts here and it ends at this point right there, because again we're defined by the T values. T only went from only up to 2, and so that's why the graph is only confined to this area right here. So now that we have that graph complete, we're ready to do elimination of the parameter. Now, elimination of the parameter is going to require some knowledge back to pre-calculus material. Okay, so here's the two equations. I had x is equal to et, and I had y equals e to the negative t. We still want to do the same process. We want to solve for t here, put it in this one, and that way we can eliminate the parameter. Now, in order to solve for t here, the best thing to do is to take the natural log of both sides. And I'm doing that because natural log on e is going to cancel out. So by doing that, I end up getting that the t value is equal to ln x. Okay, so again, ln e cancels out, you just get t by itself, and then you have ln x left over here, so that's our t value. Now we're going to take this and put it back into the other one. We have y equals e to the negative, instead of t, I'm going to put in ln x. So now I have that. We can think of this right here, the negative, you can think of that as negative 1 times ln x. And the only reason why you want to think of it that way is if we use our log rules, you can take negative 1 and move it and put that up there on top of the x. So then we have y equals e to the ln x, and we'll go ahead and put the negative 1 up there. It's another log property, so again that's why you want to go back and review your log properties to look at that. You have an e and an ln together, that's going to both cancel out, and you end up getting y equals x to negative 1, which is the same thing as 1 over x. So this right here, y equals 1 over x, that would be eliminating the parameter with these two. So it doesn't look like, with these equations given with logs, you expect your answer might have a log in it, but actually it's not. Your answer actually is a rational function. So actually we're just looking for part of the graph where if you have 1 over x, the vertical asymptote would be at 0. So you have one piece of the graph like this, and you have another one that would be down below there. So we're actually only looking at one small portion of the rational function. So even though we have e's right there, technically your equation has to do with a rational function.